So let's look at area and volume part 1, and we'll start by looking at triangles and the types of questions that were asked with triangles. So the first thing to recognize is, I suppose, going back to Pythagoras as rule for Pythagoras' theorem for a right-angled triangle here, three-sided right-angled triangle. We can see that x is equal to the square root of y squared plus z squared. Z, the length of z would be equal to the square root of x squared minus y squared, and the length of y, the base for this triangle, would be equal to the square root of x squared minus z squared. And the important formula for the triangles in the area and volume chapter is that the area of a triangle is equal to half the base times the perpendicular height of the triangle, and this side or length, the perpendicular height, is that length or side that is perpendicular to the base that we're using. Okay, so in this triangle, this is the base and this is the height perpendicular to it. In this triangle, this is the base and this is the height h perpendicular to this base, and for this one, this is the height h perpendicular to that base there. Okay, so the types of problems you will get, or questions you will get in this section, would include three main types. So the first type is where you're basically given a value for base and a value for the height, the perpendicular height h, and you just use the formula area equals half the base times the perpendicular height. So that's straightforward enough. The second one is where you're actually given a value for the area itself in centimetres squared or metres squared, and you're either given the base or the height, and you just find the other unknown. Okay. The third type is a little bit more interesting and it's more difficult. We'll have a look at this one second. So the third type is where you're given a right-angled triangle and there's some internal height h in the triangle. So often you're given the area, you're given the dimensions of the three sides, 10, 6 and 8, and you're asked to find the area, and following that you're asked to find an internal height h. Okay, so the area is straightforward. That's half the base, which is this here, times the perpendicular height. Remember, this side is perpendicular to the base here, so it's 24 centimeters cubed, and then we're asked to find h, the internal height. So we just let the area, 24, we've just calculated that, equal half by 10, because we're calling this our base now, and we're using our internal height h, which is at a right angle to the base in the second part. Okay, so we have 24 equals a half by 10 by h. That means that 2 times 24 is 48, is equal to 10h, so h is equal to 4.8 centimetres. Move on to parallelograms, and just to remind ourselves that a parallelogram is a quadrilateral shape. It's four sides, and for a parallelogram, the opposite sides are parallel. Okay, so this is parallel to this, and this side is parallel to that side. Okay, and the sum of the internal angles is 360 degrees. So the formula for the parallelograms is the area is equal to the base times the perpendicular height. Okay, and that's denoted here, or here, or here, but it is the same height. And the types of questions you get for parallelograms are where you're given the base and the perpendicular height h to it. You just simply plug those in and find the area. Or like before, you're given a value for the area and you may be given the base or the height, then you find the other unknown. And then the third type, which is a bit more interesting, gives us something like the area of a parallelogram, and it asks us again to find some internal height h. Okay, where this internal height h is always at a right angle to some other side, which becomes our base. So if the area is 70, in this problem, the area is 70 centimeters squared, find h. We let the area equal to our base times our h, okay, because this side is perpendicular or at a right angle to h. So 70 is equal to 8 times h, therefore h is equal to 8.5 centimetres. And also in this chapter we met with the trapezium, which again is a four-sided shape, a quadrilateral shape, with at least one pair of parallel sides, okay? And the parallel sides of the trapezium here are A and B, okay? And the formula for the area of a trapezium is the area is equal to the sum of A plus B divided by 2 times h, which again is the perpendicular height of the trapezium, okay? And again, the type of questions you're given with these are you're given you're given A, B, and H, and you find the area, or you're given the area and you're given A and B, and you find H, or you find one of the other unknowns. Let's look at circles and sectors, and before we do that, let's just remind ourselves of what pi actually is or means. Pi, for any circle, pi is the ratio of the circumference divided by the diameter. So this is the value of the circumference of the circle divided by the diameter, and it's always equal to 3.1416, never-ending number. Okay, and it's on your calculators, usually a second function key. You'll see the symbol pi, and use that for your calculations. So for the circle, we just remind ourselves, a circle with centre O and radius r. The area of the circle is pi r squared, and the circumference, or I suppose another word we could use is the perimeter, is equal to 2 pi r. And for a sector, with radius r, a length AB, and an angle in degrees here x, the area of OAB, that shaded area, is equal to x over 360 times pi r squared, or the length of the arc AB is equal to the angle x divided by 360 times 2 pi r. So we'll just look at the types of questions that we meet with circles and sectors. The first is where you're maybe given the radius of a circle or an arc and the value of x, and you have to find the area, the circumference, or the length of the arc using the formula. Straightforward enough. The more advanced problems are something like a running track, where you're given a running track here of 70 metres, I suppose diameter of that semicircle there, and 100 metres across of the rectangle that is there, but you don't see it, okay? And you're asked to find the area in metres squared, and having done that, maybe find the cost to sow grass seed at 5 cents per square metre. Well, the area of the shape is simply, the semicircle plus the other semicircle on the other side, plus the rectangle in the middle. And if you think about it, the two semicircles make a circle plus the rectangle. So the area of a circle is pi r squared, and the area of the rectangle is 70 by 100, and that gives us 7,000. And pi by r squared here, we use 35 because that's 70, so half of that must be 35. The radius of these two semicircles is 35. So pi r squared works out at 3848.45. Add that to your 7,000 here, and you get an area of 10848.45 metres squared. And to find the cost in cents of sown grass seed, well, if it's 5 cents per square metre, you multiply that by the area, and we can see that it's 54242.26 cents. So we divide that by 100 to get our value as 542 euros and 42 cents. And here's another example where we have a running track. We have a running track, and let me set this up. We have a running track that has that's made again of a rectangle and two semicircles, one at each end, of radius r equals 100 over pi, and we can see the points A, B, C, and D denoted on the running track, and the length L. And the question says, if the perimeter is 400, find L. And then the part 2 is a 1500 metre race, starts at A, going round through B, C, D, back to A. At what point will the race finish, if it's a 1500 metre race? And finally, a runner completes the 1500 metres in 3 minutes 26 seconds using speed equals distance over time. Find the average speed in metres per second. So we'll have to change that minutes and seconds, 2 seconds to proceed with that one. But we'll start with finding L. So they're telling us that the perimeter is 400, and we can know by the shapes that the perimeter must be 2 times L. It's this L and this L, plus this length CB, which is the length of an arc, and this length AD. Okay, and we can see that CB and AD are half circles, and therefore the length of each of those, the circumference of a full circle is 2 pi r, so the circumference of a half circle must be half that, and must just be pi r. Okay, so if we plug in our values here, we see that we have 400 is equal to 2L plus pi r for the one half circle over here, plus pi r for the other half circle over here. Okay, and so 400 equals 2L plus pi times r, and we know that r is 100 over pi, so we simply plug that in there. And 400 is equal to 2L. Well, this pi and this pi cancel, and this pi and this pi cancel, plus 100 plus 100. 400 is 2L plus 200, so we'll bring over our 200 over this side, it becomes minus 200, so we get 400 minus 200 is 200 is equal to 2L. L must be equal to 100. Okay? And if we think about then for part 2, after 3, if L is equal to 100, this is 100, and this is 100, and we have our pi r values here as 100 as well. So the track is 400 metres long. We knew that from the perimeter. If it starts at A, if we go around 100, 200, 300, 400, and another lap brings us to 800, and another lap brings us to 1200, with 300 more to go. So that's 1300, 1400, 1500. It stops at D. The finish line is at D. Okay. And finally, to find the speed using speed equals distance over time, well, we have to convert 3 minutes 26 seconds. It's 3 by 60 seconds plus 26 at 206 seconds. So speed equals 1500 divided by 206. Sorry, you can't see that there. But that's all equal to 1500 divided by 206, 7.3 meters per second.